Today we're going to take our external C# trainer tutorial. We're going to take that source code and we're going to add in a DLL injector. And I want to mention that this is just a very basic create remote thread injector. If you want to learn a lot more about C# injection, you can check out Akion's Bleak source code, which has a number of different methods and extensions. And that's actually his old library. He has a new one called Lunar, which is a lightweight native DLL mapping library. Mainly, we're talking about manual mapping. So if you're looking to get into some of the cooler stuff, check those out. So this video is going to be for beginners, basically. And we're going to go down here, download this source code, okay? Let's just rename this solution to C# injector. And if you remember from last time, we just set up, we basically were exposing the Win32 native API methods to our program by creating this GH namespace and this GH API class. It has all the structures and function declarations using the pinvoke method. If you'll remember, the regular Win32 API is not exposed to you in C#. So sometimes you need to use pinvoking to get access to those. So the reason we're using this old source code is so we don't have to re-import all of these things again. And then in our main program, we just had a simple trainer. We were going to get rid of all of this and we are just going to add in an injector. So our goal here is just to be able to call one function. So we're basically just going to call, we're just going to do bool result equals GH API dot inject DLL. And we're going to pass in the location of the DLL, which is for me is this. Now, if you don't have your own DLL to inject, you can download this one. We're just going to do it for Assault Cube. You can download it from this thread. I'll link it in the description. And we are going to pass in next the name of the executable, which is going to be ac_client.exe. Make sure you include the .exe. You're going to see that later. Make sure you're using double slashes because you need to escape that slash, right? And then after this, we're going to return. So let's go over to our source header file here, and we're going to add in our new function inside of that class, which is inside the namespace. And this is going to be a public static bool inject DLL, and we're going to pass in a string named DLL path and a string named proc name. Inside of this function, we want to find our process, right? So we're going to do a process procs equals process dot get processes by name, and we're going to do path dot get file name without extension and pass in proc name, and that's that. And this should just be path, and it's not compiling because we need to add in the special pathing, right? So that's going to be using system IO, and we just need to capitalize that F. Once we get that list of processes, we want to make sure it's not empty. So we're going to do if procs dot length equals 0, and this should be like so. Then we want to just return false. We're actually going to do some error checking here. And then we're going to do process proc equals procs 0 because we want to get just the one process. And then we're going to do get proc ID. So int proc ID equals get proc ID. And we're going to pass in proc name. And then this is just a secondary example to show you some different ways of doing things. So we're going to do int pointer hproc equals OpenProcess, and we're going to pass in process access flags dot all and false, and then proc dot id. Now we're going to do if proc dot handle does not equal int pointer dot 0. And in here, we're going to use virtual allocate to get a location to put our DLL. So it's going to be int pointer location equals virtual allocate ex proc dot handle int pointer dot 0 max path allocation type dot commit and allocation type dot reserve. So we want both of those types, and memory protection dot read write. Next, we're going to do if loc dot equals 0. I'm basically showing you two ways to do it here. You could compare it against int point 0. You could use this method. You could also do this. There's many different ways to do it, and that's all of them. So just to show you an example. So if this, we're just going to return false, and then we're going to do int pointer bytes red equals int pointer dot 0, and we're going to do bool result equals write process memory, and we're going to pass in proc.handle location DLL path.toChar array and DLL path.length. And then we're going to do an out bytes red. That's just saying that's an output variable. If not result or bytes red dot equals 0, then we also want to return false. If that gets past all of our error checking, we're going to do int pointer load lib addy equals get proc address get module handle kernel 32.dll and load library a. Then int pointer h thread equals create remote thread proc.handle int pointer dot 0 0 load lib addy location 0 and then out with an underscore. We're just going to throw away that last variable. I don't care about it. And then we're going to do if h thread does not equal 0, then we want to close handle h thread else return false. And then under here, we're going to do else return false here. And then we have proc.dispose and then return true. Next, we're going to fix up all these includes, and then I'm going to explain to you how every line works. So first thing we need is get proc ID. I did not show you that in the last video. But if you scroll up to get module base address, it's almost the same thing. If you've done the C videos, you know that this is basically the same thing. We're going to change this to get proc ID. It's going to return a proc ID, and it's just going to take a string proc name. And here, we're going to change this line to int proc ID equals 0. And then create tool help 32 snapshot. That's going to be the same, except we're going to use process instead of snapshot flags, okay? And we don't need a proc ID here. We're just going to send in a 0 for false. This is a capital P. If hsnap int64, that's still correct. And then this is going to turn into process entry 32. And we're just going to swap those out in each line that uses it. And mod entry is going to turn into proc entry. And so we'll move those over too. Mod name is now proc name. And module 32 first has to now be process 32 first and process 32 next. And it's not SZ module name, it's SZEXE file. And we don't want the base address, we want the proc ID. So we're going to set proc ID to proc entry dot th32 process ID. And I believe we have to cast that to an int. And last thing, we just need to change that mod entry to proc entry. So there it is. This is the same thing basically, except we're getting the proc ID. And we need to change the return variable type to an int. And there you go. So same thing, we get all the processes with create tool help 32 snapshot. If the handle is not invalid, we'll get the proc entry and we need to set the size of it correctly or else the whole function doesn't work. I want to say something real quick too. Like when I make these tutorials, the code is written in exactly the way it needs to work. We get a lot of people who they watch the tutorials and then they change the code and then they ask us why the code doesn't work. It's because you changed it. Stop doing that. But anyways, we need to set the size correctly, process 32 first, and then we loop through all of them and we grab the process ID. Easy enough. So once we've gotten that process ID, this needs to be int pointer, and we're going to open process. Now virtual allocate EX, that's a function we need to pinvoke. So we just go over to pinvoke.net, take a look at what they've got. This is a C# signature, so we'll grab that. We'll go to the top above our functions to where basically our pinvoke imports are, and we can paste that in. And we also need, because we're using virtual allocate, some of the arguments include memory protection and allocation type. So those flags are right here. So we'll grab them, drop those in right above that. The next thing we need is max path. So we can go back up here and we'll do public constant int max path equals 260. And if we go down here, next thing we need is get proc address. So again, we go to pinvoke, grab that signature, and we need get module handle. Here's get module handle. And then the last thing I think we need is create remote thread. Again, that's right here. This thread start delegate is not defined. You can see there's two signatures offered here. The second one just uses an int pointer, so we don't need that thread start delegate type. So now that should be good. And then we're missing a comma right there. And now this should compile. Cool, it does. All right, so let's explain this whole thing for you. So get processes by name is the managed function. So this will remove the extension, and then we pass that to get process by name because that's how this managed function works. If the length is 0, then the process is not running, and we're just going to return. Um, Otherwise, we're going to grab the first process because we're going to assuming you're only running the game once and put that into proc. We're showing you just a second method of doing things here. We're getting the proc ID by using process name. But proc also exposes to us a bunch of things like handle. So we have proc.handle, we have proc.id. So you don't actually need this function. We have the managed method to do it, but I just want to show you multiple ways of doing everything. Now, similarly as well, OpenProcess, we actually don't need to call this, but I wanted to show you, get you more experience with pinvoking and exposing those Win API functions. As we can see here, proc.handle works just fine. So these are actually both examples. So we'll just separate that in the code there. Then we're going to call virtual allocate ex, pass in the handle. The second argument we don't care about, max path. This is how many bytes we need basically to write the DLL path name. Remember, we're not actually writing the DLL into memory, we're just writing the DLL path. Remember, we're not actually writing the DLL into memory. We are writing the path of the DLL, and then later we call create remote thread, and we call load library there. So all this is doing is putting the path, and that's the path that we define right here. So the allocation type is we need it to be committed memory and reserved. And we're doing a bitwise OR right here. So basically, this is setting both of these bit flags for commit and reserve, which is what we want. And then we just need a read and write access. We don't need to execute because we're just writing the path. So if virtual allocate returns 0, then something's gone wrong. We're going to return false. Now, bytes read is our output variable, and we're using that for error checking here. So we call write process memory, and we pass in the handle, the location of memory where we want to write, and then we're taking DLL path, which is a string, and the managed string has this member function to char array, and we're getting the length of that char array. So we're just writing that string to memory, and then we are getting the bytes read output. We're checking the result, and bytes read for error checking. If something's gone wrong, we return false. And then we're going to call load library. So in order to get the address of that function, it's an exported function called load library A, the ANSI version, and it's exposed by kernel32.dll. That's what exports it. So get module handle will get you the address of kernel32.dll. So the get module handle is a Win32 API function, but we actually do this a different way too. We get module handle. The handle is just the base address of the module. You can also do get module base address and pass in the proc and kernel32.dll as a string. So that will give you the same thing. So we're actually going to test both of those things here. So this is just another example. Once we've got that load library address, we're going to call create remote thread, pass in the handle. We don't care about this argument. We're going to pass in load library and the location, and that's the memory location. So what we're basically doing here is we are calling the load library function, and we are passing it its argument, which is location, which is basically a char pointer, which is the path of the DLL. And then if hthread equals 0, does not equal 0, then we need to close the handle. The return will be 0 if something's gone wrong. And then at the end of this, if anything goes wrong, we return false. Now, we don't actually need to close handle hthread because we're using these managed process classes, right? And they have a member function called dispose, which will take care of that all for you. So you can close it manually, or you can just dispose at the end. So again, this is just like a little example to show you some more. And then at the end, we return true if it worked. All right, let's now see if it works. We got assault cube loaded. We are going to start the debugger. And remember, this is running as administrator because of our manifest file is set to require administrator. And let's just step in, and we're going to do get process by name, and that's going to get us a list of procs. You can see the length is 1, and if we open it, the first process we have is AC client. That's good. Then we're going to take that proc and just assign it to proc. We're going to show you get proc ID. This is just an example function. We'll set a breakpoint on basically the return result and continue, and you can see that it's got the proc ID correctly. We're going to break, CloseHandle, return the proc ID, OpenProcess as well. We can see that once we step over that, hproc is 0x464, and you'll notice it's a different handle value as the managed code got for itself. So we have two different open handles right now, no big deal, just showing you for an example. Now, if the proc handle is not 0, then we are going to use a virtual allocation EX, and you can see location is now 0x640000, so it got a memory address. That's good. We don't need to return false. Set bytes red to 0. We're going to call write process memory now. So let's open Cheat Engine, and we're going to get that location. And let's go to memory view. We can go to address and paste that in. And now we can step over this, and you'll now see that there's our string. We can step over this error checking. We have a get proc address. First, it's going to call get module handle, and we are going to get an error. And the reason, let's go to get module handle, and you can see that it's entry point get module handle W set last error equals true. So the problem with that is that's not what we want. We want to do char set equals char set dot auto. We want this to be using, it's basically going to set it to use ANSI when we do that. Okay, so that's interesting. You'll see core DLL.dll. That is not what we want. This should be kernel32.dll, but now this should work. Continue again, get proc address, step over. We now have the correct address. We can confirm we've got the right address. Let's grab it and let's look at Cheat Engine. This is kernel32. And if you have show symbols clicked, you will see load library A. So we have the right address. So this is now our second method of calling get proc address by using get module base address to return that function. So let's see if that works the same. And that actually didn't work either. So the reason the second line doesn't work is let's look at get module base address. So if we go here, we have two different functions, okay? We have a managed version that uses the process class, and then we have our native method that takes a proc ID. And so if we go back to our code here, this needs to take proc.id. The second part of this is our string compare in that function is case sensitive. So kernel32 is all in caps. So that's what that will look like. So let's run this again here. We can see that load lib address is right here. If we step over that, we can now see that these are going to match up. So if we click continue, kernel32 all in caps. Beautiful. Now we can call create remote thread. So I also want to just put in here must be case sensitive, correct. Okay. So now we're going to call create remote thread. Let's just click continue now. And now if we go back to our game, our DLL is injected. Cool. So that's how you make a C# injector. Real quick, I wanted to mention we used get module handle and get proc address to get the address of the exported load library function. But there's actually, in system runtime interop services, there is a native library class that has get export functions. And so this is what you would want to use if you're a cool C#er. I really hope you enjoyed this video. Again, guidedhacking.com/donate, patreon.com/guidedhacking. Please support us so that we can continue to make videos, and peace out.